Hi everyone, welcome back to another lesson of Earth Science. Today we will continue Unit 10 Climate, and we are on our third topic about climate change and global warming, and we're going to discuss the impacts and mitigation of global warming. Now, there are many different impacts of global warming that we're going to discuss. We're not going to be able to discuss all of them, but here are some of the main ones that are going to come out of global warming, as we are starting to see now, and as studies by thousands of different scientists and climatologists have found. The first one is about temperature, and temperature on Earth has risen about 1.3 degrees Fahrenheit over the past century, and they're expecting it to increase 2.5 degrees Fahrenheit to 10 degrees Fahrenheit over the next 100 years. So you can see in the pictures below that on the left side, you can see how climate has changed, how temperature has changed in specific locations. If you look at the key, the diagonal slashes just means that there's not enough statistics to fully validate it. And on the right side, you can see two different models. You got the model on top and the model on the bottom for the mid-21st century and the late 21st centuries of how temperature may change. One thing to really note is one of the major concerns about this type of climate change, global warming, is not that the climate itself is changing. We studied before that, climate does change. It has changed on Earth. It has been way hotter than it is right now. That's not the issue. The issue is how quickly the climate is changing. And the climate is changing and temperatures are increasing so quickly that species do not have the time to adapt to these changes. So a lot of species are starting to essentially get wiped out because they can't adapt to these increases in temperatures as quickly as humans can. They don't have air conditioners and we do. Another important factor with temperature is that a lot of the time, polar regions up north, they get impacted the most with the temperature changes. So although the temperature change on Earth could rise 2.5 to 10 degrees Fahrenheit over the next century, that temperature will be greater at the poles. And one of our concerns with that is in the northern latitudes near the poles, there's something in the soil called permafrost. And permafrost is essentially frozen subsoil. And within that frozen subsoil is trapped methane gas. So as that subsoil is thawing with an increase in temperature, more greenhouse gases in terms of methane is being released into the atmosphere, which is contributing to an accelerated increase in temperature change. The next factor that we're going to discuss is increasing sea level. And since 1880, so over the past 120, 140 years or so, sea level has risen on average around the globe 8 to 9 inches, which doesn't seem like a lot. But over the next century is expected to rise at least another foot. And the increase in sea level has to do with two things. The first one that most people think of is glacial melt. So as glaciers, continental glaciers like Antarctica and Greenland are melting, they're increasing the level of water in our oceans. But another thing to be aware of is something called thermal expansion. So as the temperature of the water increases, the water molecules itself start to expand. So the water essentially grows in size through this process. Another issue with that means that the water is getting warmer. So we're actually seeing a migration of different marine organisms to different parts of the world so that they could survive in the temperature conditions that they're used to. Another issue with sea level rise in terms of global warming is that 40% of the United States population, just the United States population, lives along the coastline. So although some people will not experience it, and a foot does not seem like a lot, if you live along the coast or along water, you are going to experience these climate changes. And some models were created to show what's going to happen. And here is a model of the New York City area if we were to reach an extreme amount of sea level rise. I believe this model is showing about 12 feet of sea level rise, which is possible, especially it's been found in some studies that could happen over the next century. And you can see the difference between Manhattan Island today and Manhattan in 100 years or less than 100 years from now. And you can see it zoomed in on the financial district that the streets down there will essentially turn into rivers. So sea level will have a huge impact, or global warming will have a huge impact on sea level. The next one is precipitation patterns. So some regions are going to experience more drought. There's going to be more heat waves, less precipitation in some regions, while other regions will experience more rainfall. So in those regions that are going to experience more drought, there's going to be an intense amount of evaporation. So whatever water is there is going to evaporate. Transpiration from the plants is going to happen more. It's going to become very dry, but that moisture needs to go somewhere. And so although you'll have droughts, which look like there have been more occurring on the west coast of the United States, there'll be more precipitation elsewhere because that moisture needs to go somewhere. And just something that's interesting to know is every 1 degree of Celsius you add, each degree of Celsius can hold 7% more water vapor. So warmer temperatures are able to hold more water vapor. Another impact of global warming is that there will be an increase in wildfires. Something that we have started to notice, and it's something that will also contribute to an acceleration of greenhouse gases entering the atmosphere. But we're also going to see an increase in severe weather frequency. So it is hard to determine whether storms are going to be impacted by climate, but the trends that we have seen do support that data. And finally, another impact of global warming is going to be an impact on human health. The first one is increased temperatures are going to increase death rates. When you have higher temperatures, you have more strokes, you have more dehydration, more cardiovascular and respiratory issues. And studies have clearly shown that higher temperatures equals greater mortality and greater morbidity. And you can see in this graph, this is just from one city in 1995, you can see that lower temperatures are associated with lower death rates and higher temperatures are associated with higher death rates. And this has been studied for a very long time and it's very consistent. Another effect on human health is there's going to be a decrease in air quality. There's more pollution. There's more bad particles in the atmosphere. So there'll be more asthma attacks, more cardiovascular and more respiratory issues. There'll also be an increase in what I wrote as storm-related illnesses. That's because there's going to be a decrease in water supply the more storms you have. There's going to be limited access to hospitals and supplies because if there's a major storm and roadways and bridges are damaged, you won't be able to get to a hospital if you need to. And then there's also a mental health concern. If you suffer through a large loss, especially associated with a storm, there's going to be mental health issues there. And that has been something that has been studied over and over again. And another factor on human health, or another impact on human health, is vector-borne diseases. Now, there's a little bit of uncertainty about this. There's a lot of factors that influence vector-borne diseases. A vector is something that can carry a disease. So, for example, fleas and ticks and mosquitoes, even rats are considered vectors. So a vector-borne disease, an example of ones that can make changes in terms of increase with temperature is malaria or dengue. You can see in the picture on the right, the red shows where malaria could go if there are continued increase in temperature. A lot of vectors, especially mosquitoes, like warmer temperatures, so they'll be able to thrive for longer times of the year at higher latitudes with global warming. But not all hope is lost with global warming. There are different things that we can do to help out the situation. That's where mitigation and adaptation comes in. Mitigation just refers to reducing something. So in this case, we're trying to reduce the amount of greenhouse gases so we can reduce the impact of global warming. So one mitigation is to reduce greenhouse gas emissions. And there's many different ways to do that. The main one is to switch to renewable resources. We can go to solar power, wind power, hydraulic power, nuclear power. Instead of driving cars, you can use electric bikes, or electric cars. You can bike around, you can walk. These are all different ways to mitigate greenhouse gas emissions. You can even pass, or the government can pass laws that can regulate these greenhouse gas emissions like they have done in Europe. In order to adapt, though, because it's inevitable that it is going to happen based on these studies, there has to be adaptations that can help protect people. You can build seawalls and levees. This is going to reduce the impact of rising sea level as well as storm surges. And you can see in this diagram here, there was actually a proposed plan to build essentially a seawall around the New York City harbor to protect lower Manhattan, Staten Island, and Brooklyn from increasing sea levels and storm surges like we saw with Hurricane Sandy. And here is a picture of a gate, a seawall that was created in the Netherlands to protect themselves from rising sea levels. Another way is to implement green infrastructure. That means green roofs, planting trees, restoring wetlands. There's a Queens Library on Main Street that has a green roof. Its roof is made up of grass. You can see this diagram here. This is from Staten Island. They restored the wetland area. And having restored wetlands is actually really good because that's going to reduce the impact of severe storm and storm surges because all that energy gets absorbed by the wetlands. And here you can see a lot of these on the side of the roads, but this is going to reduce the amount of flooding because now water is able to flow into there and naturally get into the ground instead of backing up the sewer system. And there are many, many, many other ways to mitigate and adapt to global warming. Again, it is not the end of the world. Starting with reducing greenhouse gas emissions is going to be a great step forward, but it's not going to solve the problem immediately. It's going to take years for us to get back to normal and to reduce the effect of the greenhouse gases. So we will need to mitigate as well as adapt for what's going to come. And a lot of people do wonder, well, a lot of these things are based on governments. How do you help with reducing global warming and greenhouse gas emissions? And here are 10 steps that you can take yourself to reduce or slow down global warming. You're not going to stop global warming like the top of the article says, but you're going to reduce its impact. So these are 10 different things that you can do. And again, there are many, many, many different impacts and mitigations and adaptations that you can take towards global warming. And we have not listed all of them. So again, I implore you to do your own research and find reliable sources that can tell you what you can and can't do. And those are the main things you need to understand about the impacts and mitigation for global warming. Have a good day.